This is structural analysis. It means that if a force is applied to this surface as an example, or this surface, while the other surface, say for example this back surface, is fixed, you want to see what is happening. You remember the idea of stress and strain? Yes, so we can find the value of stress, the value of strain in different points of this specific part as an example. So what are the steps? You go to simulation. Of course, before that you have to go to add-ins and add your. So what I do, how to make sure that this option, which is simulation, is installed, I go to setting, okay, add-ins, and make sure that these two parts are checked. Okay, so if you want to work with any add-ins, you can activate it from here. Okay, so press OK. Now you are provided with this type of simulation, which is a structural analysis for your case. Start from here, new study. Of course, before that you have to make your model. Okay, and I say the simplest case is static. Static means our model is stationary, not moving. Okay, so what happens is that I have different options here. So I start from top, try to define all options. The first thing that I need to do, let me just play with this. So the first thing is that you can say, for example, apply type of material. You right click on it and on your part. If you have 3 parts, 4 parts, each of them can be done. When you open the part, a window will be open and you have an option to select different type of material. Say for example this type of steel, you apply it. Now the material for this part is the steel that you have chosen already. Okay, so this is done. Okay, the second one is how this part is connected to the business. Here it says we have connections. Okay, we want to see how this geometry is related or is contact. We can define contexts. As you can see, you can define a spring there, we can define pin, so on and so forth. So we can talk about how context looks like here. Okay, if there is any part fixture, we can fix it like this one. You might know from roller, what's roller, slider, those things in your mechanics of material in UCL. Yeah. So you can define and say, for example, this is installed on a roller, or this is fixed. It says fixed. You mean this one? Say yes. Which face or edge is fixed? As an example, I say, look, this face is gonna be fixed. So you fix this face. Okay. Now you have to define load. What kind of load is applied? I say, for example, do you have force? Do you have torque, pressure? For example, for your case, you have force. This force is due to the pressure of the solid, okay, of the water. So this force is distributed. It's not point load is distributed. You have to define distributed. For your case here, just make it very general case, simple one. Say for example here you can apply it on surface, side surface, on edges. Okay, you can apply it in different directions. Say for example I apply on this edge as an example. I can change the value, as you can see here. You can change it here. You can make it here. Say for example this is the force, whatever force we have, you can change it. You can change the unit, you can change the direction and everything here. Reverse the direction, look, or give it the same direction, and if you're happy, then you are done with this part. Look, this is done, this is done. Now the next part is we actually make our part gridded, lots of grids, so that it can do the calculation. So I go to here and create mesh. We just leave everything as the default. Okay, we do not change it. So what will happen, you see, after a while, lots of calculation, you see it will be gridded. Each of them has lots of calculation to find the value of displacement in each of these nodes here. So there's one node here, one node here. So this program will start to do calculation, how much this one goes downward, how much this one goes downward, and then find the value of stress and everything from that point. Okay, when you are done with this, then this is a very simple case. So what I do now, you have to run your program. Okay, if anything is missing, then you will end up with error. Okay, so you see now it shows that it's elapsing, everything is fine, apparently it's working, and you see some results. Okay, it's actually kind of exaggerated, but that's what we're expecting. You see, on this part we had forces, it goes down, you can find the stresses. You see red regions are a stress concentration, okay, in red regions, okay. So red regions are dangerous regions, are critical regions. We have to avoid them or try to reduce them. Then by changing the shape you can find how we can smooth, we can reduce this value. Also you can choose strong material so that it can withstand against this load condition. Okay, so this is a very general introduction about structural analysis.